So in this section 7a and 7b, we're going to talk about probability. And probability, as we saw in the Venn diagrams, we talked a little bit about this idea of how things overlap and also if they are happening at the same time, which is an overlap, if they are separate outside of the Venn diagram. So we're going to use that idea of our Venn diagrams and tables to help us better understand probability. And so first, the definition of probability is it's a proportion. It's a proportional relationship, or it's a proportion between, and a proportion is a fraction. Okay, so all of our probabilities are a fraction. So a proportional relationship between the number of times an event occurs the number of times that event happens over or versus or against the total possibilities or the total number of outcomes, number of possible outcomes. When we talk about probabilities, we have to talk about their notation. So you're going to see P, and that means the probability. And then in parentheses, we're going to talk about whatever that event is, whatever we're talking about. So P of the event. Or sometimes we'll also see this tilde and P of the event, which means the probability that the event does not happen. So the probability that the event happens, and then if you see the tilde, then it's the probability the event doesn't happen. And just as a refresher, just to recall that a relative number is a percentage, and percentages can be written as decimals or fractions. And so when we talk about our theoretical probability, so there's three different types of probabilities: theoretical, empirical, or sometimes known as relative frequency, and subjective. And theoretical is based on the definition. So the definition and theoretical probability go together. This is the fraction. We're going to talk about how those fractions are. So it's written in fractional form, and we do not simplify that fraction unless answering in Pearson, and Pearson always wants you to simplify your fractions. But we're going to talk about why we don't want to simplify our fractions. So let's just do some examples. So the probability that we get a 3 on a dice or on a die. Well, there is 1, 3, and there are 6 possible outcomes. So 1 out of 6. And what is the probability of getting a 2 or a 3? Well, there are 2 possible outcomes for a 2 and a 3. So that happens either you get a 2 or you get the 3 and the 6-sided dice. So notice that the 2 represents how many possible events there are, and 6 is the total amount of outcomes. If we simplify this to 1/3, now we're talking about one outcome or one possible thing, and we have a 3-sided dice. And since this is not true, we're rolling a regular dice which has 6 sides, and we have 2 things that happen. So this is why we don't want to simplify our fractions, because they tell a completely different story. Yes, the value is equivalent, but we don't want to misconstrue what the definition of a probability is. So we leave it as 2/6. How about the probability that somebody is born in November? Well, if we're born in November, that's 1 out of 12 months. However, if we talk about somebody that's born on April 1st, and now we have 1 day out of 365 days. So now we're talking about a specific day. So that's 1 out of 365. If we're talking about the month, it's 1 over 12. What about the probability of, say, a black king on a deck of cards? Again, here we don't want to think about simplifying it. We have 2 black kings in a deck of cards, and there are 52 cards in a deck. We don't want to simplify this because that tells a different story. All right, so now let's talk about the empirical, or what sometimes Pearson will call the relative frequency. So most of these are written in decimal or percentage form. And the empirical probability is what we call the man-tested, or what you're thinking about is manually flipping the coin so many times, or throwing the dice. So we're testing this theoretical probability. And so if we wanted to figure out what the probability of getting a 3 on that dice is, or on that die, but we're doing this empirically. So that means we're going to test this. We're going to figure out what that is. So I have a website here that will help us do that test. And so right now I have, if you look at this spinner, we have a 4-sided die. So I want a 6-sided die. So I'm going to get six different colors. And it really doesn't matter which color we choose because there's an equal probability. So 16.67 is the same thing as 1/6. So let's just, I don't know, let's pick blue since it's the first one. That'll be, or actually, since we're figuring out the probability of 3, so we'll do 1, 2, 3. So gray will be our number 3 on our dice. So if we spin this one time, well, the probability is 1 out of 1 because it landed on gray. Well, we know that probability is not a 1. Okay, so the probability of this first time was 1. Well, if we do it again, if we get a 3 on the die and we do it again, so we want a new experiment and we're going to roll the die, so we're going to spin it, and this time it's a 0. So this time our probability is 0. So we know that the probability is supposed to be 1/6. So let's do the probability of rolling this die, but let's do it after 100 times. So when we do it 100 times, so we're going to do a new experiment. We're going to change this to 100. And now we're going to spin that wheel, which is like simulating throwing a die. And now we end up with 22 out of 100. And that's a 22%. So now we ended up with 22 out of 100, or the probability of rolling that 3 on a die after 100 times is 22%, and the theoretical probability is 16.7%. So as we roll the die more and more times, we get closer and closer to that theoretical probability. So empirical probability is what we do. Theoretical probability is the actual calculation. And just keep in mind that the more times we do this, so the more tries we do, the closer we get to the theoretical probability. And actually, this is what the casinos bank on. So it's closer we get to the theoretical probability. Okay, and the last type is the subjective probability. this is really what does your gut tell you? So this is your experience or maybe what your gut says. And so what is the probability of an accident on the freeway? Well, depending on who you are and how often you drive and all those things, you would say it's probably pretty close to 100%. Now, it can't be 100%. That would mean it would always happen, but maybe we're going to say it's 99.9%. What is the probability that it's going to be a sunny day tomorrow? Well, we're going to use what we know from maybe today. Maybe we're a weather forecaster in terms of we like to watch the news. So, based on our experience or based on some things that our gut is telling you, maybe we're going to say it's about 77%. Notice that your subjective probabilities most likely will be written as percentages. Your empirical probabilities are either sometimes a fraction, a percentage, or a decimal. Your theoretical probability is always written in fractional form. So those are the three types of probabilities as we talk about the whole idea of probability.